PowerShell scripting, from command to script to module. This is where we're really going to start on our path for PowerShell tool making. We're going to take a basic command that we can run in the console to make sure it works, turn it into a script, parameterize that, and then turn that script into a distributable module. This is also where I'll introduce you to PowerShell script modules. The goal is to eventually work up to something that looks and smells and feels and tastes as much like a real PowerShell command as possible. Taking the scripting fundamentals that we've covered up to this point, this is really where that journey begins. And we've got a very definite narrative to tell in this nugget. We're going to start by writing a command and then turn that into a parameterized script, which we will then enclose as a function. Now, those are things we've already done in previous nuggets, but now we're going to take the last step and package it as a module that can contain multiple functions, all of which can be loaded into the shell or loaded out of the shell, unloaded from the shell as a single unit. And this is your first step on the path to truly becoming a tool maker. Not just someone who pushes buttons for a living, but someone who actually makes the buttons for other people to push. You're creating reusable units of automation. You're creating tools that other people use to get their jobs done. This places you at the top of the IT pecking order and really moves you into the world of DevOps, which is the big thing everyone wants to talk about, but it's the same concept that's been around in the IT industry for more than 3 decades. Operations folks, administrators, who have enough development skills to create tools to solve problems rather than running around and solving those problems manually every single time. This is really the narrative, the story of how you get there. And we're going to be taking these skills and building on them a lot in all of the upcoming nuggets. And we'll start with my boilerplate phrase that everything I'm going to show you is applicable to PowerShell version 2 and later. I'm going to be working in PowerShell version 3 because I like the tool better. This ISE is just easier to use. So I always begin at the console. Now this time we're not going to do the standard old get WMI object. Let's do something instead with, I don't know, get event log. Let's just run get event log because again, the command we're running is a lot less important than what we're going to do with it. So let's retrieve the latest 50 security event log entries from a remote computer. Okay, that appears to have worked. So I can grab this command, copy it to the clipboard, and start a new script. And let's go full screen. There we go. Paste that in. We'll save this. And I'm going to call it get latest security log.ps1. Again, I'm giving it a commandlet style name. Get the verb and then latest security log tells me what this thing really does. There we go, a script. I want to parameterize it. I don't want someone to have to come in here and actually edit that computer name, so I'll create a parameter for computer name. And I'll use that parameter instead of my hard-coded value. Save that, and just to play with it a bit, I'm going to drop down here to a normal PowerShell console. Let's do a get latest security log minus computer. Look at that tab completion action dc.lab.pri. So it works. Now, I could actually stop right here. In fact, if I ask for help on that script file, there's even some basic help built into it. So somebody who's learning how to use PowerShell can start using this tool right away. The downside to this approach, though, is that each file can only do this one thing, right? I can't have multiple tasks built into this file. So to help solve that problem, I'm going to bundle this into a function. And before I do that, I'm going to change the name of the file. mytools.ps1. And to make this a function is really simple. Function get latest security log. I'm immediately going to put my closing bracket, and I'm immediately going to indent everything inside. Boom. Now just to test that, get latest security log. Oops, we don't want to run the script. We want to run the function minus computer name dc.lab.pri. Now I'll run this script. This will define the function, and that will run the function to make sure that it works. And it did. Excellent. Oh, could not be read to completion. Oh, the log may have been cleared or something while it was being read. That's fine. These things happen. So I'm going to take this out, and I've now created a little script that could potentially contain multiple different commands. In fact, let's play with that. Let's go back to the console. Let's do get sim instance class Win32 operating. Let's do BIOS. It's shorter. Win32 BIOS from the computer name dc.lab.pri. Okay, that command works, so I'm going to copy it to the clipboard. I'm going to make a function, get OS info. I'm going to give it a parameter, which is a string, computer name. I will paste my command, close my function, and instead of my hard-coded computer name, I'll use my parameter. Now I can test it. Get OS info. Oops, need a dash in there. OS info, computer name, member.lab.pri. Let's see if that works. There we go. Works fine. So I've got two functions now that live inside of this file. The only problem is I can't really easily use either of those because they're kind of trapped in this file. Now I could come over here and certainly run mytools.ps1, but because the script ran, defined the functions, and then stopped running and the functions went away, I don't have get OS info here. Now I could show you the trick that I showed you a couple nuggets ago about dot sourcing this. That would load those functions into the global shell, but that's not a very elegant means of doing it. This is where it's time for us to move into something called a module. Now this can get a little bit tricky, so I want you to pay very, very, very close attention. The magic here in PowerShell is not that strong, so you've got to really do things exactly the way it wants, or the magic won't work. I'm taking this exact file. I'm not changing a single thing inside the file. Save as. I'm going over to my documents library and expanding it to make sure that I hit my documents instead of public documents. In here, I have a folder called Windows PowerShell, all one word. That does not exist by default. If you don't have that on your computer, in your documents folder, you're going to have to make it. Then you will create a folder called modules, and then you will make a folder. Here's the tricky bit. Make a folder, and this is where you get to name your module. I'm going to call this My Tools. Inside that folder, you have to save the file with the same name. The folder is called My Tools, so the file has to be called mytools.psm1. As soon as I do that, you'll notice I can no longer run this inside the ISE. The ISE can't run a module. Instead, to test this, import module mytool. Now, I'm going to tab complete, and it's going to work. Get OS info computer name dc.lab.pri. Notice that there's no path in front of this. I'm not running a script. This is a command that has been loaded into memory as part of this module. Get latest security log, computer name, dc.lab.pri. See, both of those commands work. Here's the cool part. Remove module, my tools. Get OS info, still there? Hard to tell. It's actually what it's doing is it's tab completing that, because even though the module is not loaded, it knows the module is on disk. It knows that command is in the module, and it will load it for me. Look, if I run get module, my tool's not loaded. Get OS info, somehow it's still here. It's because PowerShell automatically loaded it. If I run get module now, it's loaded. You can see it there at the end of the list. Now let's say I need to make a change to the way that thing works. I need to remove the module so I can go make my changes, save the file, and then reload the module so that PowerShell will read the new version into memory. Otherwise, you wind up making a bunch of changes, hitting save, you come back over here and none of your changes took effect because you have to reload the module. Now let's talk a little bit about how the magic works, because I said there was magic and I wasn't lying. There's an environment variable, $env ps module path. This environment variable is defined by Windows, meaning if you want to change it, you have to come out into Windows and go to the control panel and do that. Or you can change this with a group policy object. This is a semicolon separated list of paths where PowerShell will look for modules. And by looking in these paths and by storing your module in one of these paths, you make sure that your modules can be discovered and automatically loaded. Now, if you don't have them in one of those paths, you can still use import module with a complete file path. Right, that'll still work, but by putting them in one of these paths, you make it very easy. So you'll notice this is the one I use. My Documents folder, Windows PowerShell, Modules. If we look in that location, you can see I actually have 3 modules, Help Desk Tools, My Tools, and OS Tools, all available there. So I can import module Help Desk Tools, import module OS Tools, whatever I want to do. Inside those folders, the PSM1 file has the same name as the folder, OS Tools, OS Tools. That's the way it has to work. This other path is where PowerShell, or well, Microsoft, keeps their modules. So all the core operating system modules live in that location. You're not really supposed to put yours in there. You can add a semicolon and another path, maybe to a file server, and that can become a central location where you store the modules that you want to share with your team. So we've taken a command, built it into a script that accepted a parameter, enclosed that into a function so that we could put multiples into the same file, and then simply saved that file in a special place using a special file naming convention so that PowerShell can treat it just like a real command. Help get OS info. Not the prettiest help in the world, but it has the basic form of a help file and it shows me the parameters that are available. We're going to find out how to make that look a lot nicer in upcoming nuggets. But this is our first step toward really getting into a reusable tool. By building this into a module, we've taken the first step to becoming a tool maker. So we wrote a command, we made it into a parameterized script. Now that right there is making a simple tool someone can use. The only problem with it is that every single time you create a tool, it's got to be in a separate file, and it makes it a little bit tough to keep track of them all when you start building up a big library. So to help solve that problem, we enclosed it in a function. Enclosing that script as a function gave us the ability to put more than one of them into a single file, and that file is a packaging mechanism called a script module. That is your first step to becoming a PowerShell tool maker, creating tools that can be redistributed, loaded as a group, unloaded from the shell as a group, and used in a consistent fashion by other folks who are learning to use PowerShell or who already know how to use it. I hope this has been informative for you, and I'd like to thank you for viewing.